Let's go through the list. Is there a greatest common factor? No, other than one, no. Is it a trinomial? No. Is it the difference of, well, no, it's not a difference, it's a sum. And it's not the difference of squares for sure. Is it the sum or difference of cubes? Yeah, because that's what we're studying. But also, it truly is. So here's the deal. You have x cubed, which is x cubed. No surprises there. And you have 1,000, which is 10 cubed. It helps to know your cubes. So it might help for us to make a list of perfect cubes. We'll take care of that in a few minutes. So this is what I'm dealing with. So I recommend that we write the formula. There are two formulas. Let's go back for a second. They're here. And I'm going to write the top one. And you don't have to, well, I say you don't have to memorize it. You do have to memorize it. But there are some shortcuts that deal with the signs and things like that. So let's write the formula. If it's a sum of cubes, then I would have a cubed plus b cubed. And that would be, oh, let's just go ahead. AB, a squared, AB, b squared, and we'll figure out the signs. So same sign, opposite sign, and then always positive. Spell soap. Okay, so in this case, and it might help to do this sometimes, and it will definitely help on the next problem, I like to write down sometimes what A is x, and then what B is, and B is 10. I'm going to stretch this one out a little bit longer than it probably should be. That way we can gain a better understanding going into the next one, which will be a little bit trickier. So let's keep going. We have A plus B. Well, that would be x plus 10. Okay, well, I can do that. X plus 10. All right, A squared, that's x squared, minus A times B, that's x times 10. Put x times 10 if you want to be wrong. Put 10x if you want to be mathematically correct. And then plus b squared, so plus 10 squared. And this is where I'm stretching it out an extra step. If you want to skip this step and just go ahead and put a 100 here, you can. I'm not yet, because I want to get in the habit of looking at this and saying, what do I need to simplify? And that's what I need to simplify. And that'll happen again on the next problem. So x plus 10 there, and then x squared minus 10x plus 100. X squared minus 10x plus 100. All right. Fun times, fun times. So let's scroll up and let's do another one, and it's going to be a little bit trickier. It's 8x cubed minus 27. So this guy right here, yeah, tricky. GCF? No. Trinomial? Quadratic? No. Difference of squares? No. Difference of cubes? Yes. So what I want to do is identify what's cubed, like what exactly are we dealing with? And it might help, and I'm going to back up for a minute, and along the same lines of the sum or difference of cubes, I'm going to make a list of perfect cubes, and it'll be a good way to identify the cubes. So here goes. And just wherever on this paper you want to, or a scrap piece of paper or something, this list is going to come in handy. 1 cubed is 1. That was useless. 2 cubed is 8. 3 cubed is 27. You do have some notes actually that have all of them listed up through 10. I'm going to go through 12 actually, but they have them, but they're not listed as directly as this. So 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed, how about I get out of your way here? 7 cubed is sliding. 343. 8 cubed is 512. 9 cubed is 700 and... No. My mind just went blank. Oh no! 9 times 9 is 81. Yeah, 729. Yeah, that's right. Yeah. 10 cubed, you better know this one, it's 1,000. 11 cubed, this one's interesting. For reasons I don't want to go into right now. Pascal's triangle, if you really want to get nerdy with it, is 1,331, and then 12 cubed is, my mind just went blank. 1,000. I'm going to grab a calculator. Once I see it, I'm going to smack my forehead and say, I knew that. I forgot that. 1728. Helps to be familiar with them, particularly on the lower end. Up on the higher end, you can try it in a calculator if you need to. Clearly, I forgot 12 cubed. I generally know that one. All right, let's go back to here for a second. And the purpose of that list, you could go back and pause that if you need to, but the purpose of that list is so we can identify what's cubed here. So on the list, 8 was 2 cubed. Okay, well, then there was x cubed, and then there was 27, which was 3 cubed, and there's a whole lot of stuff going on here. Let's clean it up a little bit. 2 cubed x cubed, that's 2x cubed minus 3 cubed. Okay, that's what we're dealing with, which means as we write our formula in blue, it's for fun, then we'll have a cubed minus b cubed, and that is really going to help me to identify what a is. It's 2x, okay? So I want to point out something different here about this one. There was a coefficient in front of our x cubed, and that's going to mean that we have to deal with the cube root of that number too, that cube root of that coefficient, which was 2. And so I have 2x all cubed, which would give me 8x cubed. And then I have b, which is 3, all right? So as I write this formula from memory, a, b, a squared, ab, b squared. Let's do signs. Same, opposite, always positive. As I write the formula, I'm able to figure out the structure of this thing. Slide up for a second. I'm able to figure out the structure of this thing and say, well, a is 2x and b is 3. So let's just go ahead and start writing. It'll take a couple steps to get there. But we're going to have, let's see, a minus b. That's 2x minus 3. So far, so good. And then a squared. Wrong, okay? This is not 2x squared. This is 2x, all, the quantity, squared, okay? In a minute, we're going to square the 2 and square the x. Very common mistake people do there. Plus a times b, and then plus b squared. All right, let's start simplifying some things. Now, when I say simplifying in this context, a lot of people say, well, let's just multiply 2x times this and this. No, 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 no. You'll end up back where you started. That's not what we want. We wanted a factor. What I am going to do, though, is look at these individual terms and multiply some things where necessary, starting here. 2x minus 3 doesn't change. And then here we have 2x all squared. So 2 squared is 4. X squared is x squared. So we have 4x squared. 2 times 3, 6x. And 3 squared is 9. And again, this does not factor. They generally don't in this context. I'm straining my brain to think of a context in which they would. They might if you have craziness going on that we're not going to deal with. So we're done factoring. You could try all day to factor that. It won't factor. If you use the quadratic formula on it, in case you cared, if you want to set that equal to 0 and use the quadratic formula, you would end up with complex roots. You'd have the imaginary number pop up.